In a science lab, Dominic's instructor wrote the wavelength for violet light on the board. So this thing over here, that is the wavelength for violet light. The wavelength is large or small value. How do you know? Okay, Landon says that it's a small value. Okay, but why?
So how many zeros?
Yeah, but zero doesn't necessarily make it small. We'll say the decimal has several zeros after it.
Oh yeah, that's what I was implying.
I know, but it wasn't what you said. Okay. So we know it's small because there's a decimal and then a bunch of zeros. Okay. And can anybody tell me what value that actually is?
100,000?
Yeah, it's 100,000ths because this is tens, tenths, hundredths, thousandths, 10,000ths, and 100,000ths. So it's not quite as easy going backward as it is going forward, right? So the correct place value here is 4, and then 100,000ths. 100,000ths. Man. So what makes this difficult is that when we get really, really big numbers and really, really small numbers, who wants to count all those zeros before we actually understand what it is? And do any of us really even understand what 400,000ths is?
You spelled thousands wrong.
It's okay.
Okay, yeah.
There's a U somewhere in there, right?
Yeah.
Is that better?
Yeah.
Okay, thanks. So I can't spell. If you see something, just let me know and I'll try to fix it. Okay, so we don't want to count all those numbers all the time. So instead of doing that, scientific notation is a shorthand of writing really big or really small numbers. It's a way to write these things in a shorter way that is nicer to see. So it's written as a product of two numbers. Product. Product means what? Multiplication. Product means multiplication. Okay. And the number must be between 1 and 10. Okay, between 1 and 10. And the second number must be a power of 10. A power of 10. And just as an example, what I mean by power would be like 10 to the 5. 10 to the 5. Okay. And that value means 10 times 10 times 10 times 10 times 10. The 5 is how many tens? Okay. So is that okay? Does that make sense so far? Now, what is that value? What's 10 times 10?
100.
Times 10?
1,000.
Times 10?
10,000.
Times 10?
100,000.
So this value is 100,000. Okay? 100,000. How many zeros are in 100,000?
5.
Ah, there's 5 zeros in 100,000. What was this number here? So the number of zeros and that thing will match. So that's an easy way to know if you've got the right number of tens. Okay. Now, how do we create these things? How do we create these scientific notation? Okay. So first thing we do is we create a number between 1 and 10 by moving the decimal. Okay, we're going to move the decimal. And then you're going to count how many times you do that. And that's going to be your power. And the reason this works, sorry, let me fix my handwriting. Okay. The reason this works is because of 10, because of us using the base 10 system. If the original value was greater than 1, the exponent will be what? What do you think? We're going to positive. And if your original value, like a decimal, the exponent would be less than 1, like a decimal, the exponent would be negative. Okay, and so let's look at 2 examples over here, and I'll show you what I mean. So, first thing I'm going to do is I'm going to try to make this thing over here a number, this thing right here, a number between 1 and 10. So I'm going to move the decimal until that happens. So, is it between 1 and 10 now?
No.
No. Is it between 1 and 10 now?
No.
Now?
No.
Now?
No.
Now?
No.
Now?
Yes.
Yes. So I'm going to write that down. 6.98. Okay? I'm just going to write down the part that is got the numbers there. Generally, we're going to leave 2 decimals behind the decimal. Sorry, 2 digits behind the decimal, like I did here, 2. Occasionally, you'll see 3. Okay? So now, how many times did I move? 1, 2, 3, 4, 5, 6. I moved the decimal 6 times. So we're going to write times 10 to the power of 6. Times 10 to the power of 6. Now, why is it positive? Because my original is greater than 1. So the reason that this value here is positive is because it's greater than 1. Greater than 1. Okay, so now we have a decimal for the second one. Let's do the same thing. Let's count. I'll do it in blue. 1, 2, 3, 4, 5, 6, 7, 8. Now, should I stop here or should I keep going? Is 8.3 going to be between 1 and 10?
Yes. No.
Yes. So I'm going to have 8.3. Now, how many times did I move in order to go from here to here with the decimal? How many times did I move? 8. So times 10 to the 8. But is this bigger or smaller? So this is smaller than 1. So we need a negative 8. So this thing is smaller than 1, so it's got to be negative.
Wait, are we supposed to solve the times 10 to the power?
Nope. I was just doing that to show you why it works.
Okay.
So, positive, bigger than 1, you get a positive. Smaller than 1, you get a negative. And that's it. That's it. That's all we're doing. Okay? So let's try a few more. Do you guys want to try 1 through 4 on your own, even though we
Yes,
just...
please.
Okay, great. So try it, and I'll walk around if you've got questions, and then we'll do it together. Remember, when you move the decimal, even numbers that aren't zeros still count as part of your numbers. So if you move it over and you have only like 3 zeros, but then there's 2 other numbers you move it past, those still count towards your number. So times 10 to whatever that value would be. So how do I get this to be less than 10 and between 1? What would it be? 1.85, right? So write down 1.85. And then now how many times do you have to move the decimal to get the Now, on the calculator, sometimes it will display times 10 as E. So if you ever see it on the calculator, 33.5 E to the 7, E means the same thing. And it will be a capital E. Yes, sir.
So,
This one.
yeah, so when I put it on zero behind it.
So remember, it has to be between what two numbers? 1 and 10. So is that more than 1?
Nope.
No, so you need to move it even further. So, yeah. And then only count the decimal to this position though, right?
Okay, yeah.
You don't, because those zeros are still behind it, right? Okay, it looks like most people have got the first 2 or 3 done, so, would someone like to volunteer for number 1?
I shall.
Okay.
1.850 times 10 to the power of 6.
Okay, 185 times 10 to the power of 6. Okay, this thing is bigger than 1. So it's bigger than 1. It means this has got to be positive, so that's good. And then let's check 6. 1, that's not the right thing. 1, 2, 3, 4, 5, 6. Great. So 1.85 times 10 to the 6. Okay, good. Someone else? Yes, sure. Oh, hold on. The same person or a different person?
Me.
Okay, yeah. And then Raphael, you can do number 3.
4.2 times 10 to the 4th power.
Okay, so once again, this number is bigger than 1. So that needs to be positive, so that's good. And then 1, 2, 3, 4. I agree. Okay. Raphael?
Third one.
Uh-huh.
7.826 times 10 to the 3rd power.
Negative third. Good. And so once we'll check, this is less than 1. So we want to make sure that that is negative. And then let's check 1, 2, 3. Yes, we moved 3 times. Great. Landon, you do the next one?
2.1 to the power, or times 10 to the power of negative 6.
Times 10 to the negative what?
6.
Negative 6. Okay, so less than 1. You said it backward, but I think it's 1.2. 1, 2, 3, 4, 5. Okay, so 5. So because I have to hit the back button. 5. So negative 5. Okay, that's fine. Not a big deal. Right? Great. And less than 1. So that's where the negative comes from. Now, what if this thing was negative? Then, or what if that thing was negative? Is that going to change these things?
No.
All that's going to change is the sign in front is going to be a negative. Okay? So if it's in front a negative, then there will be a negative in front. That's the only thing that it would change. Yes, sir?
But will the power number still be
The power numbers will still be the same because what they mean, they don't mean, in the notes it didn't say this, but it means the absolute value of that number being greater than 1, not the number being greater than 1. How far is it from 0? If it's more than 1, then you're good. Okay, now the wavelength up there was 0.00004, and so we want to move that over. We have to move it to past the 4, so 4.00 times 10, and let's count them, 1, 2, 3, 4, 5. Have to move it 5 times the negative direction. Okay, any questions about those 5 so far? No? Okay. Now, this is just going the opposite direction, so I'm just going to go through these real quick because it's pretty straightforward. You move the decimal the same number as the power. Okay, so if it says times 10 to the 6, you move it 6 times. If it says times 10 to the 27, you move it 27 times. If the exponent is positive, Move it to which direction?
Right. Left.
Right was correct. Okay, and if the exponent is negative, we want to go to the left. And it would make the number smaller. So we're going to have bigger if we move things to the right and smaller if we move things to the left. Okay. So on this other side over here, it says times 10 to the 6. So I'm going to do 4 to 5. But I need to move it 6 times. 1, 2, and then 3, 4, 5, 6. So how many times past 5 did I move it?
6.
No.
Oh, past
4.
Past the 5. Yeah. 1, 2, 3, 4. So times 10 to the 6 should be a number that's in the millions. So same thing down here. 5, 1, 3, 8. And if I take the decimal and go 1, 2, 3, 4, 5, I get decimal and 1, 2, 3, 4 zeros. Okay. This time, why don't we just see if we can do it at the same time? So 7.83, and I'm going to move the decimal how many times?
7.
Which direction?
Left.
To the right.
Right.
1, 2, 3, 4, 5, 6, 7. So I need a 0 everywhere. And then I'll put the commas in there so it's easier to read. Comma, comma. So 78,300,000. 1, 2, 3, 4, 5, 6, 7. Okay, I got 7. Question? So is going the other way easier, harder, the same?
Going
Probably a little bit harder.
the positive way easier.
Okay, well then let's do number 8. 8.345 times 10 to the negative 6. Negative means move which direction? Left. So 1, 2, 3, 4, 5, 6. So I put my decimal and 0, 0, 0, 0, 0. So that's a really, really small number. In chemistry, you deal with numbers that are to the negative 23. So in chemistry, this is a really useful concept because you deal with numbers that are super, super small. Okay, that's a very small number. And so that's kind of why it was developed, is for those kinds of things, and like things on really big scale, like how far things are apart in the universe is massive. So we need something like this. So how many times do I move it?
Which one?
Number 7.
4.
1, 2, 3, 4. Okay, so 2, 5, 0, 0, 0. 25,000. Okay, what about the other one, the bottom? How many times do I move it? 3, but it's negative, so I'll go left. 0, 0.
Wait, but if you move it 3 times, wouldn't there be 3 zeros?
No, because I started on the other side of the 3,
Oh.
right? So you have to remember where you're starting, right? So there will either be 1 less 0 than the number, or 2 less zeros than the number, or 3, depending on what you have as a decimal. Okay.
So that doesn't help a lot.
No, it doesn't. Yeah. So we'll do 10 and 12. We'll skip 11. He's on a cruise that weighs 5.5 times 10 to the 7. So let's write that out. 5.5 times 10 to the 7. So how many times do I move the decimal?
7.
1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6. And I'll put commas in blue so we can kind of see.
That's a big number.
It is a big number, but the question is it bigger than 60 million?
No.
No, it is not. Okay, so we want to compare these two. And so the first one, scientific notation, we found 55 million. 5, 5, 3 zeros, 3 zeros. And that is not larger than 60 million. Okay. And then at the bottom, we just want to complete this table. So on the right side, scientific notation. So I'm just going to write 5.82. Why did I write 5.82?
That's the three numbers that it starts with.
It's the numbers that it starts with, and I need it to be less than 10 but bigger than 1. So now I have to count how many decimals to get there. 1, 2, 3, 4, 5, 6. Times 10 to the 6. Now it's asking to go the opposite direction. So which way do I move the decimal for a positive? Right. 1, 2, 3, 4, 5. So how many zeros do I need after my number?
5,
Huh?
4,
Huh?
3.
How many were right here? 2. 2 out of the 5. So we need 3 zeros. So 4, 2, 5, 0, 0, 0. What should I write down for my scientific notation for this one?
1.5 times 10.
And then
to the fourth power.
1, 2. How many? How many did I move? I moved 3 times. Right, we're not past the 5 yet, so I just moved that 1, 2, 3 times. And then 6, 2, 5, 7. I need to move the decimal how many times?
7.
7. So 1, 2, 3, 4, 5, 6, 7. So I've got my decimal. 1, 2, 3, 4, 5, 6, 7. Is that okay? Okay, try the assignment.